Hello everyone, welcome back to Let's Unbound. So we are in 11th episode of this particular playlist, trigonometric functions and polar functions. The 3.11 is all about understanding and exploring the secant, cosecant and cotangent functions. So we already know sine, cos, tan. These are primary functions, and based on the understanding of those functions, we will understand these things. So it's very simple and well connected one. So let's get started. Be ready with pen and paper. Here we go. So secant function, we represent the notation is secant SEC theta. Cosecant S CSE, or sometimes we will denote in this way also, and cot theta. Cotangent is cot theta. So now, the secant, cosecant, and cotangent function, they are reciprocals of sine. So you see, sine, when you reciprocate, you will get cosecant. Right. So when I reciprocate, it will become 1 by sine theta. And when denominator, if your domain value is working on something on your denominator, then if wherever your denominator becomes 0, those will have discontinuity, right? So here, sine theta will become 0 at pi, minus pi, at 0. At these places, when you see, there is vertical asymptotes, right? Also 2 pi, 3 pi, 4 pi, this side negative 2 pi, negative. So n multiples of pi, the cosecant theta function will be undefined. And due to the discontinuity, you see, there is a break-in function. And also we should able to analyze n behavior whenever a vertical asymptote pops up. And you see here at pi by 2, your sine is maximum. At pi by 2, this is being the relatively it's minimum here, right? So it's just got reciprocal, like pi by 2 comma 1 means, right? So when you reciprocate it, it's pi by 2 and 1 by 1 is still 1. So it doesn't matter. 1 by 0, like when it's 30 degree, when it is 30 degree, that means pi by 6. Sine pi by 6 is what? It is 1 by 2. But cosecant pi by 6, when you 6, it's 2. Just reciprocate them, right? Cosecant pi by 6 will be 2 somewhere over here. So this way we have to plot it and we will get this kind of function, which is cosecant. And cos theta, when you reciprocate cos theta, we'll get secant theta. Cos theta will become 0 at odd multiples of pi by 2, like pi by 2, 3 pi by 2, 5 pi by 2. There will be vertical asymptotes, also in negative odd multiples. Right? And cos 0 is 1. Right? So 0, at 0 it's 1, but when you reciprocate, 1 by 1 is still 1. So we have the same thing. Then cos pi by 3 would be 1 by 2. I'm just taking some easier values. So your secant pi by 3 will be 2. Got it? This is the way we should plot, sketch the graph. And tan theta already have some vertical asymptotes because it is itself a rational, kind of rational function, and you can write them in ratio of sine and cos, right? So now cot theta is 1 by tan theta. So wherever your tan theta is becoming 0, so it's becoming 0, it's minus pi, 0, plus pi, like multiples of pi, that pops vertical asymptotes, right? And wherever tan has asymptotes, there when you see, so here it has an asymptote, pi by 2, negative pi by 2. At negative pi by 2, it crosses 0. So wherever it original function, like tan crosses 0, cot have vertical asymptote. Tan have vertical asymptote, cot have the crossing, eccentricity there. So this is the way we will connect sine, cos, tan with cosecant, secant, and cot theta, right? And when you see all these have discontinuity, right? Only two functions is smooth, sine, cos. Those are our sinusoidal function we are using a lot, correct? In modeling and stuff. Now, secant function, let's understand one by one. Secant is 1 by cosecant theta, all real numbers except for where cos theta is 0. So cos theta, where it will become 0 at pi by 2 plus n pi. Pi by 2 plus you just add n pi, 1 pi, 2 pi, like that. And range is A cos theta will go from -1 to +1. I mean, cos theta, I'm telling. Its range will go from this. Excluding this, your secant will have the -∞ to -1 union 1 to infinity. Vertical asymptotes, of course, whenever cos the denominator becomes 0, the values which we have excluded in the domain will be the vertical asymptotes. Right? Now, secant and cosecant. So we can see secant function here, and when we see this, it just got reciprocated, right? This part is reciprocated, this part is reciprocated, and vertical asymptotes whenever it crosses. Correct? Now, next part is cosecant function. Cosecant is 1 by sine theta, and domain is all real numbers except where sine theta is 0, that theta is not equal to n pi, or you can write real numbers minus n pi, where n being integer. And range is same. Sine theta range is actually -1 to +1. Now, reciprocal cosecant theta, let's just exclude those values and -∞ to -1 union 1 to infinity. Vertical asymptote at the excluded value of the domain. Right? And here is a function you can pause and understand. Cosecant versus sine. Right? And cotangent function is cos by sine. Tan is sine by cos by sine. So wherever sine theta becomes 0, it will not be. So all real numbers from -∞ to infinity is your range. Like how tan behaves, right? It's cotangent. Tangent also has all real numbers. Period is being pi, vertical asymptotes at theta equal to n pi. Right? Now, this is the thing you can understand. Tan versus cotan is here. Just pause the video and observe this. Now, let's solve some questions. Evaluate secant 5 pi by 3. So let's start. First, whenever you see the secant, cosecant, and cotangent, I mean cot, you can just convert into the three main forms, sine, cos. So secant, where we can relate, secant theta is 1 by cos theta, right? So secant 5 pi by 3 is 1 by cos 5 pi by 3. Now, I should evaluate cos pi by 3. Where this, in which quadrant this 5 by 3 lies, we should find it. So here we go. Draw the unit circle. Wait a second. So here we go. Draw the unit circle and the quadrants. 5 pi by 3, you just, 5 by 3 is what? 1, 2 by 3. Right? So it's actually 2 pi by 3. It's not. Okay, let's do. So 5 pi by 3, let me write pi plus pi by 3. You will get just 4 pi by 3. And minus is not possible. 2 pi minus pi by 3 will give you 5 pi by 3. So any one of the quadrant, right? So in this quadrant, your 5 pi by 3 will lies. So mark that. In this quadrant, cos is positive and its reciprocal also positive. Secant is also positive. So cos is positive, but what value? So this is pi by 3 and you draw the right triangle, or by this time you might memorize all the values. What is cos pi by 3, sin pi by 3 stuff. So this is 90, this is pi by 6. So this is 30, 60, 90 triangle. And how the ratios would be? So opposite to pi by 6, it will be 1. 90, it's 2. Opposite to pi by 3, it's root 3. Right? So cos 5 pi by 3 would go. Cos is adjacent over hypotenuse. Right? So let me evaluate. Cos pi by 3 is adjacent over hypotenuse. Adjacent is +1. I mean 5 pi by 3 itself we can take. Hypotenuse is 2, so it's 1 over 2. 1 by 1 over 2. And when you solve this, it's 2. So secant 5 pi by 3 is 2. That's simple. This is the first level question. I hope it is clear. And we can move to next part. Question 2. Find the vertical asymptotes of y equal to 2 cot theta. And also let's find range for this. Okay, I will give you some time. So first I will find the vertical asymptote. So write a function wherever denominator will decide the vertical asymptote, right? So let me write 2 cos theta by sine theta minus 1. So when your denominator becomes 0, and let me make them simplify, 2 cos theta minus 1 by sine theta. Sine theta will become 0 at x is equal to n pi, where n being integers. So wherever your denominator becomes, there exists vertical asymptotes. So vertical asymptotes at x is equal to n pi. So here they use theta. So theta equal to n pi, n being integers. Okay. So change this to theta. Now, how to find the range of this function? Let's do the range part. Any function is just an example for you. So a function look like y equal to 2 cot theta minus 1. General cot theta range we know, minus infinity to plus infinity. You multiply 2 with that, it's 2 cot theta. Infinity times 2, it's going to be another big number, right? And another negative big number. Then subtract 1. So you will get your y exactly here. And it's from minus infinity minus 1, it's going to be again minus infinity. This is plus infinity. So the range is the same as thing. So range is minus infinity to plus infinity. All right. That's it, second problem. And now we are moving into the third one. Solve for all solutions in 0 to pi, cot square x plus 3 cot x minus 1. So solving trigonometric equations involving the cot. So we can see a quadratic pattern here. So for a simplicity, you can take cot x equal to some a or something. So I'm taking a. So this equation will become a square plus 3a. Okay, wait. Actually, the number should be changed. 3 cot x plus 2. Okay. For a simple solving. So 3a plus 2 equals 0. And as usual, you factorize this. Product I need 2, sum I need 3. 1 times 2, right? So a square plus 1a plus 2a plus 2 equals 0. From the first two terms, take a common, a plus 1. From here, take 2 common, a plus 1. So this just I am reiterating this. If you're solving quadratic after splitting middle term and taking the first common thing out, you should have the second binomial factor same as like this, a plus 1, then a plus 2. So now we got a is equal to negative 1, a equal to negative 2. What is my a actually? Cot x. Cot x is negative 1, cot x is negative 2. Right? I'm going to change this into tan form. 1 by tan x is negative 1. 1 by tan x is negative 2. So this will be converted into tan x is negative 1 and another tan x is negative 1 by 2. So I have to solve this equation. I know the properties of tan, right? So this is the first thing. We make them into simple quadratic, solve for it. Then we replace a with cot x and then we convert it to tan form. Right. Now here. So let's solve tan x equal to 1 and tan x equal to negative half. So tan x equal to negative 1, we need to find like this is my unit circle. Tan will be negative in second and third quadrant, right? So tan is negative here. So we'll mark this. And what is your reference angle? Tan will become 1 at pi by 4. So reference angle is pi by 4. Now, if it is in second quadrant, then your x would be pi minus your reference angle, second quadrant, right? So pi minus pi by 4, which is 3 pi by 4. And then another one is in fourth quadrant. That can be written as 2 pi minus your reference angle. 2 pi minus pi by 4 would give you 7 pi by 4. Right? So that's simple. We solve for this too. And It should be in 0 to 2 pi. If it's exceeding that, we can just neglect that. Now for this, draw the unit circle, and we can go with tan x is negative again here and here. Negative half. For this, we will use calculator. So how to find theta reference angle? Because it's not an exact value or something known value to us. So theta r is tan inverse. Don't put negative, just 1 by 2. For reference angle, don't include the sign. Just take the ratio part. So tan inverse 1 by 2. Very simple calculation. You will get approximately. Do it in radian. The entire problem, actually they give you the domain, right? We have to solve in this restricted domain. It was given in radian, so you should also do this in radian. So tan inverse 1 by 2, approximately 0.464 radian. Okay, now how to find x? Again, this is pi minus your reference angle. This is 2 pi minus your reference angle, and we can do that. So your x is going to be pi minus 0.464 approximately, and do this in calculator. You will get approximately 2.678. Just go for 3 decimal places. And another x is 2 pi minus 0.464. Again, do the calculator part. It's 5.879. So these are the solutions. Your x is 3 pi by 4, 7 pi by 4, 2.678, 5.879. Right? That's simple. The other 3 forms of function, secant, cosecant, and cotangent, right? And we complete 3 problems, and also we overviewed the concept. Now I have a bonus question for you. Solve the trigonometric equation 2 cot x secant x 2 cot x in the interval 0 to 2 pi. Right? Very simple one. And yeah, solve, and then you can try to give your answer in the comment section. Also share your feedbacks and suggestion to us. We would love to hear it from you. Thank you so much for joining with us today. So I will be coming with another episode video very soon. Until then, keep learning and keep practicing. Stay curious.